So vectors have both magnitude and direction. Oh yeah, right? You could write that at the end. Oh yeah, if you wanted to. Magnitude and direction, or direction and magnitude, whatever. Whichever way to do it, okay? Direction is indicated by a positive or a negative. Scalars only have magnitude. So recall when we would do vectors, or dealing with vectors, when we dealt with vectors, and we have a negative or a positive, often what would we have to do with our answer? Would we leave our answer as a negative or positive?
No,
We'd have to convert it, right? And change it to the direction. So, you know, say we knew that the answer was positive 20 meters or something. But really that positive represented north or something in the context of our question. So we would change our final answer so that it had north. And similarly, if you're given a question that has north or east or south or west or right or left, to do the calculation with that value, you need to translate the word into a negative or a positive. Do you recall those things? Yes? Okay, so just be remembering that you might have to translate the question into, to do the calculation, and then translate your answer back to give an appropriate thing. Okay, so scalars have only magnitude. So, what are some examples of vectors? Pardon? Cereal, okay, yeah. So in physics, which types of variables did we talk about that were vectors?
Distance and time.
Pardon? Distance and time are actually scalar. Displacement was a vector quantity. What else? What is velocity? A scalar or vector? Vector quantity, yes. And so speed is scalar. Okay, very good. All right. So you remember things. Good job. So displacement, as we just said, when we talk about displacement, remember it needs to be the D with the arrow over top of it, because the arrow over top of it represents that it is a vector quantity, giving both direction and magnitude. So displacement is a change in the distance and direction away from, in the distance and direction away from a reference point. Okay, so if I start here, this is my reference point, right? Right here. If I start and I walk this way, and then I turn around and I walk this way, what's my displacement? 0, because in regards to the reference point, I have not moved. Whatever, this like 2 meters or whatever that was. Yes, that's correct, because the actual physical movement is always recorded for distance. So the SI units, meaning like the units that we should always try and use by default and in our calculations, is in meters, so that's very important to remember. It is a vector quantity, as you have noticed. Now when we talk about distance versus displacement, let's just make a couple notes about what is what. Oh. Okay, so distance versus displacement. So let's do the example, kind of like we had just talked about. So say I start at a point. Which side do you have? You have distance on the left, right?
Yep.
Okay. So say I start at a reference point and I go 2.0 meters that way, and say I turned around and I went, say, 1 meter the other way. So the distance then, of course, is what? Just 3 meters. So it's d is equal to 3.0 meters. Alternatively, so then let's put here, so that we remember, this is scalar. Now, if I did the same thing, went 2 meters, turned around, went about 1 meter, my displacement, so d with an arrow over top, is what? 1 meter, what? This is the tricky part, right? So you think, okay, from my reference point to where I have ended, how far have I gone and in what direction? So I've gone 1 meter, and you could say either east or right would be appropriate for this context. So we'll put down 1 meter, we'll just put down right. You could put east too, and that'd be fine. But see how you need to look at from the reference point to where you ended up, okay? So just be very mindful about that. Okay, so now, as you mentioned, velocity is a vector quantity as well. Now, velocity is the rate of change, so it's the rate of change in an object's position. Rate means over time. So velocity is change in an object's position over time. Our SI units are meters per second, and indeed it is a vector quantity. So our formula for velocity is what? Remember?
V equals d over t.
Yeah. And specifically V with an arrow over top, because that's velocity. If I didn't have an arrow over top, it would mean speed. And my d over delta t. The delta implying change in time. So, where your v is your velocity in meters per second, your d is your displacement, and t is your time. And you can make a note to yourself saying that that means delta, okay, or that's what the symbol is called, and it means change. Speed is similar, but it's just the scalar version. So we have our speed is equal to distance over time. So it's just v is equal to d over t. Okay, so that's a bit of a review, but let's just do an example so that we're on the same page. So an object travels at a uniform velocity, means like the same, so it's like on cruise, of 25 meters per second west. What is the displacement of the object after 10 minutes? Be mindful of your units, right? Your units need to be meters per second for velocity, meters for displacement, and seconds for time. So that means let's write out all of our information first. When you're doing a physics equation, it's best to write out all of your data that you know about. you're trying to find your D, and you know your time is 10 minutes. So we have to do a conversion because this needs to be in seconds. So I'm going to multiply it by a fraction to eliminate my minutes and end up with seconds. So my minutes unit goes on the bottom, my second goes on the top. Think to myself, there's 60 seconds in every 1 minute. So 10 times 60, 600 seconds. So now I have enough data to do my calculation. So my formula then, you write out your formula, is d over t. So therefore, I'm trying to find displacement. It's b times t. So 25.0 meters per second multiplied by 600 seconds. Now it is tedious to write in your units, but it is very important that you do. Okay? The more you get into a habit of this, the better it will pay off in the long run. So we can see here with our units, meters per second and seconds cross off because the second is on the bottom of the fraction. Okay? So now I have 15,000 meters. Now I think sig digs. Okay? Is this in significant digits? No. I need to have 3 sig digs. So that means I'm going to have to put it into scientific notation. Okay? So for scientific notation, I have my first number, the decimal place, the second number, and I'm allowed 3 digits, times 10 to the power of. So my decimal place was here. I'm going to move it 1, 2, 3, 4 spots, and my units are in meters. So that's my final answer.
Shouldn't it have like west?
Oh, thank you.
So all those should have been negative?
Well, you could
West.
put a negative.
Yes, that is a valid statement. You could have made the distance, or sorry, the displacement negative, or, well, you know what you could have done is this. The velocity, you would say, to translate it, it'd be 25 meters, negative 25 meters per second. So then your displacement answer would be a negative and you would put it into west. When it's a question like this where distance is not, like it's not going this way and that way, it's not as imperative, but your observation to do it is very good. That you beat me. You did that. That's a better idea. Your idea was better. So should I redo it, or is that okay?
I think they're
Okay. But I'm gonna make note of that actually. Because, well, never mind. I won't tell you the next. Okay. Okay. So sometimes it is useful to calculate the average speed or velocity of something. Oh, and please, I think I mentioned it, but we didn't note. Anytime where it says uniform, think of like, okay, if you have a uniform, if we all had school uniforms, we would all look the same. So this means it's constant. Okay, my board is, well, off. So think uniform, think constant. Okay, so when we think about average velocity or average speed, so we can think, okay, V average is our total displacement over total time, okay, if we had to do something like that. So this is average velocity. Now, and then here here, if we had just V average is equal to D total divided by T total. This is our average speed. So when you think an average, think that you need to have all of the data. Now we did do this a little bit last year, but it's interesting how much your brains grow in 1 year, because I remember you didn't understand this, and I bet that you will totally get it right now. Okay? So, ready? Yeah. Don't worry about it, let's just do it. Okay. So, a runner goes for a run and ends up going 5.72 meters north and 2.0 meters south over a time interval of 3.75 seconds. Calculate the runner's average speed, then average velocity. Okay. So, A, average speed. So that's B average is equal to D total divided by T total. Okay, so I need to find my D total and my T total to even do this. So my D total is equal to all of the distance. So I'm not concerned about the direction with my distance. So 5.72 meters plus 2.00 meters. So then my D total,
7.17 meters.
yeah. And then your T total is quite simple because you just only have the one, which is nice. .75 seconds. So now you can put that into your formula. 7.72 meters divided by 3.75 seconds. .0586 repeating meters per second. Is that in sig digs?
No way.
Nope, no way. So I need 3 sig digs, so 1, 2, 3. Look at the numbers behind. So 2.06 meters per second. Okay, so that's my average speed. Now we will do average velocity. So that's my B average, my displacement total divided by my T total. So here we need to think, okay, for my displacement, now I need to include, translate my north into positive and my souths into negatives. So I went positive 5.72 meters, and I'm going to add a negative value. So think about that you're still because you're still adding them all together because you're making a total, but it's just that you're adding a negative quantity. So our displacement quantity after that is still a positive value. And my T total stays the same. So now I can put this into my formula. Make sure you're using your units. I'll take marks off your test if you don't have units. So do it now. Even if you get the answer right. Okay? So positive 0.992 meters per second. So this is a positive value, so now we're gonna translate the positive value into a direction.
North.
Yes. So our V average then is 0.992 meters per second, comma, north. Now you could put it into scientific notation, times 10 to the -1, but it's not necessary. It's, yeah, either way. So we'll do a little